Welcome back. We will continue our problems in viscosity. So now in this particular problem, they have said the velocity distribution for flow over a flat plate is given by the relationship between velocity u and the distance between the plates, which is y. Okay, and u is mentioned in meter per second and y is given in meters. Determine the shear stress at y equal to 0.15 meters. Take dynamic viscosity of fluid as 8.6 poise. So mu is 8.6 poise. So if we divide it by 10, we are going to get this as 0.86 Newton second per meter squared. And the distance is given as 0.15 meter. And then there is a relationship u equal to 3 by 4y minus y squared. What we know is tau is mu times du by dy. So they want us to find the value of tau at y equal to 0.15. So which means mu times du by dy. I'm supposed to find out the value of du by dy at y equal to 0.15 meters. So I have the value u. So now I'm supposed to differentiate this u with reference to y. So du by dy. So if I differentiate 3 by 4y, I'm going to get 3 by 4. And y squared, while differentiating, I'm going to get 2y. And now all I have to do is for this du by dy, I'm supposed to substitute the value of y equal to 0.15 meters. So that is 3 by 4 minus 2 times 0.15. So 2 times 0.15, that is going to be 0.3. 3 by 4 is 0.75. Isn't it? 3 by 4 is 0.75. And 2 times 0.15 is 0.3. So what I would get is 0.45 second to the power minus 1. Okay, so now we have got the value of du by dy at y equal to 0.15 meters. And now all I have to find out is the value of tau. So the value of the viscosity mu is given as 0.86. Du by dy is 0.45. I'm supposed to simply multiply these two values. Okay. So let me use the calculator again. 0.86 into 0.45, that is 0.387. So this guy over here is 0.387 Newton per meter squared. So that is the value of the shear stress at the mentioned distance of 0.15 meters. Okay. So this is a slightly different problem. I won't say much different, but we need to add one or two additional formula which we would have learned in other subjects or other courses. Okay. The dynamic viscosity of an oil used for lubrication between a shaft and sleeve is 6 poise. So here, this is the shaft which rotates, and the sleeve is given over here. So in between the sleeve and the shaft, you have got the oil. So that portion which is shaded by red. So this gap between the sleeve and the shaft is filled with oil. And that is what is given as the thickness of the oil film, that is 1.5 mm. So which is what we can take as y. Y is 1.5 mm, which is going to be 0.0015 meters. Okay. And they have said that the dynamic viscosity of the oil is 6 poise. So if we are going to divide it by 10, so that is going to be 0.6 Newton second per meter square. The shaft has a diameter of 0.4 meters. So diameter of the shaft is 0.4 meters. And the shaft rotates at 190 RPM. Okay. So they want us to calculate the power lost in the bearing. So what is the power lost for a sleeve length of 90 mm? So we get this sleeve length is given. So diameter is going to be 0.4 and the sleeve length, let's take it as L. So L is going to be equal to 90 mm, or let me say 0.09 meters. Okay. So now what we know is we need to find out the value of this power lost. So what is this equation for power that we have? So equation of power would be 2 pi nt divided by 60, where n is your speed and this t stands for torque, the torque of this shaft. So we need to find out the value of torque. So for torque, what we know as a definition of torque is it is the force multiplied by the perpendicular distance. So that is going to be F times R or F times D by 2. So that is your torque. The next question is, how do I find out force? The force, obviously, we are going to find out from the shear stress and multiply it with the area. Okay, so how do I find out the shear stress? So shear stress is tau is mu times du by dy, or I can say mu times u by y. So where do I get the value of uh, this u? U is not given to me directly. Y is given as 0.0015 meters. Mu is given as 0.6. But how about u? U is not given to us straight away in the problem. So we need to use the definition of the velocity. So that is pi dn divided by 60. So since we are using capital D to be consistent, let's change this as capital D as well. Okay, so we substitute the value. This is going to be 0.4. And the value of speed is 190. To convert it to seconds, we are dividing it by 60. So if we use the calculator again, so which is I times 0.4 into 190 divided by 60, that would give me 3.98. So this is 3.98 meter per second. Okay, so now I will be able to calculate the value of tau. So mu times mu is 0.6. The value of the velocity is 3.98 whole divided by y, which happens to be 0.0015. So let me use the calculator again. 0.6 times 3.98 whole divided by 0.0015, and that's going to be 1592 Newton per meter square. Okay, so we have found out the value of tau, but we are yet to find out the value of the force. We are yet to find out the value of this force, the torque, and then we are supposed to find out the value of power loss. So let's use the next page. So tau, we have found that it is 1592 Newton per meter square. The next one is we are supposed to find out the value of the force. So the force is tau times area. So tau it is 1592, that is fine. What about this area guy? So let's go back to the previous slide. So we need to find out the area. So what is this area? The area is going to be the circumferential area. So that is pi dl. So we have to use the equation tau times pi dl. And so 1592 multiplied by pi, diameter is 0.4 and the length is 0.09. If you remember, it was 90 mm. So it is 0.09 meters. So now using the calculator again, we will be able to get the value as 179.96 Newton. So this gives me the value of force. Now I have to get the value of torque. So this guy over here, tau is shear stress. And this guy, T over here, is torque. Okay, so T is F multiplied by the perpendicular distance. It is D by 2. So it is F multiplied by the radius, or in this case, it is multiplied by D by 2. So that gives us, so this is 179.96 multiplied by 0.4 divided by 2. So that gives us 35.99 Newton meters. So the power lost is going to be equal to 2 pi nt divided by 60. The value of speed is 190 RPM. The torque value is 35.99 whole divided by 60. So it should be approximately somewhere around. So this guy multiplied by 90 into 2 into 3.14 whole divided by 60. So that is 715.76 watts. Or if you want to write it in kilowatts, then it is going to be 0.716 kilowatt. Okay, so it is pretty simple, except that you need to use the equations for torque and force. That's it. So now we are able to find out the value of the power lost. Okay, then one more question over here. So this is once again a slightly different problem. If the velocity profile of a fluid over a plate is parabolic, with a vertex 20 centimeter from the plate, where the velocity is 120 centimeter per second, calculate the velocity gradients and shear stresses at a distance of 0, 10, and 20 centimeter from the plate, if the viscosity of the fluid is 8.5 poise. Okay, so here, so this is going to be the place or the origin of the plate, that is going to be 0. So the vertex is 20 centimeter from the plate. That is what is shown in this diagram. And they have said that at y equal to 20 centimeter, your velocity is 120 centimeter per second. Okay, they have said that the velocity profile is going to be parabolic. So we can write this as u is ay squared plus by plus c. This is the equation that we can have for a velocity profile which is parabolic. And if we look at the boundary conditions for that, at y equal to 0, at this particular point where the plate is fixed, at y equal to 0, your velocity of the fluid is also equal to 0. And that is what we call as the no slip condition. And then what we have is at y equal to 20 centimeters or 0.2 meters, your velocity is going to be the free stream velocity, and that is given as 120 centimeter per second. or 1.2 meter per second. So that is the second boundary condition. The third one is at y equal to 0.2 meters, that is at 20 centimeters, the velocity gradient, there is no change in the velocity, and because it has attained the free stream velocity over here. So that is du by dy equal to 0. So if I can apply these three conditions in the equation which I have written for the parabolic profile, I will be able to get the value of the constants A, B, and C. And if I can apply the values of y equal to 0, 10, and 20 centimeter in those equations, I will be able to get the value of the velocity gradients and the shear stress. So what do they mean by velocity gradient? Velocity gradient is du by dy, and the shear stress is the value of tau. Okay, so now let's go ahead and apply the values. So let me apply the first boundary condition. So let me apply boundary condition. So from the next step, I'll simply call it as BC. Let me apply the boundary condition number 1 in the equation. So if I do that, I would get u equal to 0 when a into 0 squared plus b into 0 plus c. So everything is 0. So that gives us c equal to 0. Okay, so let us apply the second boundary condition. That is that applying boundary condition 2. So now I would get u is 1.2 meter per second. That is equal to a times 0.2 the whole squared plus b times plus b times 0.2 plus c. What we know is c is already 0. So we are left with the equation 0.04a plus 0.2b, that is going to be equal to 1.2. This is one equation that we have got. Let's call that as equation Roman number 1, or let's say Roman number 1, the capital equation, capital Roman number. Okay, let me move on to the next page. What we know is u is ay squared plus by plus c. Now we need to apply the third boundary condition. Okay, let me use boundary condition number 3, which says du by dy at y equal to 0.2 meters, that is equal to 0. So first I need to differentiate this. So du by dy is going to be equal to a times 2y plus b. So that is 2ay plus b, and this is equal to 0. So I have got two equations, 2ay plus b equal to 0. And in the previous equation, you have got 0.404a plus 0.2b equal to 1.2. 0.04a. Oh, we forgot to just a moment. So we need to substitute the value of y equal to 0.2 over here. So du by dy at y equal to 0.2 is only equal to 0. So it is 2a times 0.2 plus b is equal to 0, which is 0.4a plus b is equal to 0. Let's call this as equation number 2, Roman number 2. So previously we have got 0.04a plus 0.2b equal to 1.2. Now we have got 0.4a plus b equal to 0. So if we solve this, if I say, if I'm going to divide the second equation by 10, so that would give me 0.04a plus 0.2b equal to 1.2. If I divide the second equation by 10, I will get 0.04a plus 0.1b equal to 0. And if I subtract the second equation from the first equation, I would get 0.1b equal to 1.2, or b is equal to 12. So b is 1.2 divided by 0.1. So that would uh, cancel the decimal places on both ends. So you will get b equal to 12. So if I substitute that in the second equation where I have 0.4a plus b is equal to 0. So 0.4a plus 12 is equal to 0, or 0.4a is minus 12. And so a is equal to minus 12 by zero point 0.4, or it would be minus 120 by 4, which is minus 30. So A is minus 30. So the first question is they want us to find the velocity gradients. So that is du by dy. So du by dy was 2ay plus b, and so 2ay plus b. Now we know the values of a and b. So minus 60y plus b is 12. So now in the previous slide, they want us to find it in 0, 10, and 20 centimeters. So du by dy at y is equal to 0, you would get the value of 12, that is 12 second to the power minus 1. Then du by dy at y equal to 0.1 meter, that is 10 centimeter. So you would get minus 6 plus 12. So that is 6 second to the power minus 1. And the third one is du by dy at y equal to 0.2. So that would be 0 second to the power minus 1. The value becomes 0. So they also want us to find the value of tau. So tau is mu times, or let me use the space over here. So tau is mu times du by dy. So the value of mu was 8.5 poise. So if I say mu is 8.5 poise, if I convert it to Newton second per meter squared, I am going to divide it by 10. So that is Newton second 0.85 Newton second per meter squared. So this guy is going to be 0.85 multiplied by du by dy. So if you want to find tau at y equal to 0, that is mu times du by dy at y equal to 0. Mu value is 0.85. The value of du by dy at 0 is 12. So 12 into 0.85, that is going to be equal to 12 into 0.85 is 10.2 Newton per meter squared. Okay, that is our first result. Then tau at y equal to 0.1. That is mu times du by dy at y equal to 0.1. So that is 0.85 multiplied by 6. So that is 5.1 Newton per meter squared. So tau at at y equal to 0.2 is mu times du by dy at 0.2. du by dy at 0.2 is 0. So 0 multiplied by anything is going to be 0. Okay. So that is what we get when we solve this particular problem. So we will stop here and continue in the next lecture.